Hello guys, for this time I would like to talk about the Arcanet like uh, transmission power tower for electricity. A transmission tower or power tower um, is the structure, usually a steel lattice tower used to support an overhead power line. In electric power grids, they are generally used to carry high voltage transmission line that transport bulk power from generating station to electrical substations. Utility poles are used to support lower voltage sub-transmission lines and distribution line that transport power from substation to electric customer. They come in a wide variety of shape and size. The typical heights range from 15 to 55 meter or 49 to 180 feet. Through the tallest are the 370 meter or 1,214 feet towers of 2,700 or 8,855 feet span of um, the power line. In addition to steel, other materials may be used, including concrete and wood. There are four major categories of transmission tower: suspension, terminal, tension, and transposition. Some transmission towers combine these basic functions. Transmission towers and their overhead power lines are often considered to be a form of visual pollution. Some methods to reduce the visual effect include undergrounding. The transmission tower is the name for the structure used in the industry in United States and some other English-speaking countries. The term pylon comes from the basic shape of the structure, an obelisk-like structure which tapers tower the top, and the name is mostly used in the United Kingdom and part of Europe in everyday colloquial speech. The term is used frequently in the most region in the United States. Their three-phase electric power system are used for high voltage 66 or 69 kilovolt and above, and extra high volt 110 or 115 kV and above, most often 138 or 230 kV and above in contemporary system. AC transmission lines. In some in Europe country, for example Germany, Spain, or Czech Republic, smaller lattice tower are used for medium voltage above 10 kV transmission lines too. The tower must be designed to carry three or multiples of three conductors. The tower are usually steel lattice or trusses. Wooden structure are used in Canada, Germany, and Scandinavia in some cases. And the insulators are either glass or porcelain disc or a composite insulators using silicone, rubber, or EPMD rubber material assembled in strain or long rods. Wall lengths are depends on the line voltage and environment condition. Typically, one or two grounds wire, also called girth wires, are placed on the top to intercept lighting and harmlessly divert to the ground. Tower for high and extra high voltage are usually designed to carry two or more electric circuits, with a very rare exceptions, only one circuit for 500 kV and higher. Um, if a line is constructing using towers designed to carry several circuits, it is not necessary to install all the circuit at the time of construction. Indeed, for economic reasons, some transmission lines are designed for 3 or 4 circuits, but only 2 or 3 circuits are initially installed. Some high voltage circuits are often erected on the same tower as 110 kV lines. Paralleling circuits of 380 kV, 220 kV, and 110 kV lines on the same tower is common. Sometimes, especially with 110 kV circuits, a parallel circuit carries transmission lines for railway electrification. For high voltage DC transmission tower, lines are either monopolar or bipolar system. With bipolar system, a conductor arrangement with one conductor on each side of the tower in use. On some schemes, the ground conductor is used as electrode line or ground return. In this case, it had to be installed with insulator equipped with surge arrestor on the pylons in order to prevent electrochemical corrosion of the pylons. For single pole HVDC transmission with the ground return, towers with only one conductor can be used. In many cases, however, the towers are designed for later conversion to two-pole system. In this case, often conductors on both sides of the tower are installed for mechanical reasons until the second pole is needed. It is either used as electrode line or joined in the parallel with the pole in use. In the latter case, the line from the conductor station to the earthing grounding electrode is built as underground cable as overhead line on the separate right of way or by using the ground conductor. Electrode line towers are used in some HVDC schemes to carry the power line from the converter station to the grounding electrode. They are similar to structure used for lines with voltage of 10 to 30 kV but normally carry only one or two conductors. AC transmission towers may be converted to full or mixed HVDC use to increase power transmission levels at a lower cost than building a new transmission line. For railway traction line towers, tower used for single phase AC railway traction line are similar in construction to those towers used for 110 kV three-phase line. Steel tube or concrete pulleys are also often used for this line. However, railway traction current system are two people assist system. So traction lines are designed for two conductors or multiple of two, usually 4, 8, or 12. These are usually arranged on the one level, where each circuit occupies on half of the cross arm. For 4 traction circuits, that arrangement on the conductor is in the 2 level, and for 6 electric circuits, the arrangement of the conductor in the 3 level. AC circuit of different frequency and phases come, or AC and DC circuits may be installed on the same tower. Usually all circuits of such line have voltage of 50 kV and more. However, there are some lines of this type of lower voltage. For example, tower used by both railway traction power circuits and the general three-phase AC grid. 2 very short sections of the line carry both AC and DC power circuits. One set of such a tower is near the terminal of HVDC, Volgo Grid, Donbass on Vol Hydroelectric Power Station. The other are 2 towers south of Stenkullen, which carry one circuit of HVDC Kontiskan and unit circuit of the 3 phases AC line. Tower carrying AC circuit and this electro line exists in the section of power line between Alderstedt Interplan and Brockton-Wittenberg of a DC square butter. Tower design. Number 1 is shape. Different shapes of transmission towers are typical for different countries. The shape also depends on the voltage and number of circuits. One circuits, Delta Pelton, are the most common design for single circuit lines because of their stability. And number 2 circuits, one level batons only have one cross arm carrying 3 cables on each side. Sometimes they have an additional cross arm for the protection cable. They are frequently used close to the airport due to their reduced height. Number 3 is 4 circuits. Christmas tree shaped tower for 4 or even 6 circuits are common in Germany and have 3 across arm, where the highest arm has each one cable, the second has 2 cables, and third has 3 cables on each side. The cables on the third arm usually carry circuit of lower high voltage. For support structures, tower may be self-supporting and capable for resisting all forces due to conductor loads, unbalanced conductor, wind and ice in any direction. Such towers often have approximately square bases and usually 4 points of contact with the ground. A semi-flexible tower is designed so that it can use overhead grounding wires to transfer mechanical load to adjust structure. If a paced conductor breaks and the structure is subject to unbalanced loads. This type of is useful in extra high voltage where passive conductors are bundled two or more wire per phase. It is unlikely for all of them to break at once, bearing a catastrophic crash or storm. The materials: turbulent steel, polished made of turbulent steel, generally are assembled at the factory and placed on the right way of the wood. Because of its durability and easy of manufacturing and installation, many utilities in recent years prefer the use of monopolar steel or concentrate tower over lattice steel for new power line and tower replacement. From lattice. A lattice tower is a framework construction made of steel or aluminum section. Lattice towers are used for power lines of all voltage and are the most common type for high voltage transmission line. Lattice towers are usually made of galvanized steel. Aluminum is used for reduced weight, such as in mountainous areas where structures are placed by helicopter. Aluminum is also used in environment that would be corrosive to steel. The extra material cost of aluminum tower will be offset by lower installation costs. Design of aluminum lattice tower is similar that for steel, but it must take into account aluminum lower Young's modulus. A lattice tower is usually assembled at the location where it is to be erected. This makes very tall tower possible up to 100 meter equal 328 feet and is especially cases even higher as in the assembly of lattice steel tower can be done using a crane. Lattice steel towers are generally made of angled profile steel beams for very tall tower trusses are often used. Number two, from wood. Wood is a material which is limited in use high voltage transmission. Because of the limited height of available trees, the maximum height of wooden pylons is limited to approximately 30 meters or 98 feet. Wood is rarely used for lattice framework. Instead, they are used to build multiple structures such as H-frame and K-frame structure. The voltage they carry are also limited, such as in other regions where wood structure only can voltage to up approximately 30 kV. In countries such as Canada and United States, wooden towers carry voltage up to 345 kV. This can be less costly than steel structure and take advantage of the surge voltage insulating properties of wood. Number three is concrete. They usually with the power lines with operating voltage below 30 kV. In exceptional cases, concrete lines are used for 110 kV lines as well as the public grid or for railway traction current grid. For special design, sometime in particular or steel lattice tower for the highest voltage level, transmitting plants are installed and antennas mount on the top above or below the overhead ground wire. Usually these installations are for mobile phone service or the operating radio of power supply from but occasionally also for other radio service like direction radio. Those transmission antennas for lower power FM radio and television transmitters were already installed on pylons. There's a tower there, a radar facility belonging to the Water and Navigation Office. For a cross-board valley, a large distance between the conductors must be for the conductor must be maintained to avoid short circuit caused by conductor cables colliding during storm. In order to drop overhead lines into step, the pallets in inclined tower are occasionally used. These are utilized at the Hoover Dam, located in the state, the Dexter of in Colorado. In Switzerland, a pylon included around 20 degrees to the vertical allocated. Uh, they use 380 kV pylon in Switzerland. A power station chimney are sometimes equipped with crossbar for fixing conductor of the outgoing lines because of a possible problem with corrosion by flue gases. Such construction are very rare. Okay, guys, let's go check it out. This this tower electricity. I took the video when I drove before I come home to us. Let's go check it out. Thank you guys for watching my video. I hope you enjoy my video. Don't forget click like, comment and subscribe. Thank you. Have a nice day.